Hello, everybody. Okay, so we are going to be looking at these 2 points, and for this example, I'm actually going to calculate the long way. What is the point? Half the distance from A to B. So, really, we already know what the answer is going to be. The answer is going to be the midpoint. And we can calculate the midpoint quickly to see what our answer should be. So let's do that. So my midpoint is the average of my x's. So that would be -2 plus 4 over 2. And my y is 8, -10, so that's going to be 8 plus -10 divided by 2. And this simplifies down to be 1, comma, and then -1. So this is the point that we're expecting to get from this, but we're going to do it in the fractional distance way. So I'm going to kind of place A and B roughly where they need to be. So this is going to be my A. This will be my B. And I'm going to just sketch a line down to them. Okay. So, with distance, we actually are using, essentially we're making a right triangle. Okay. So there's my right triangle. Now I need my length of my vertical and the length of my horizontal. So the length of my horizontal is, if we're being technical, the absolute value of my x values subtracted from each other. So this. And -2 is +2, so we have 4 plus 2, which is 6, and we have the absolute value is 6. So in class, I have referred to this as my delta x. We do not have to refer to that in that notion technically. All we need to know is that this length here, my horizontal distance, is 6. Okay. Now we also need our vertical distance, and we find that the same basic way. So my vertical distance are going to be my y subtracted from each other. So absolute value of -10 minus 8, which is -18. Absolute value makes it 18. And this is that side length, whereas this is that side length. Okay, so we now have those two values. So this is where we come into play with the fraction part of our problem. We want something that is half the distance from A to B. So roughly like there. And if we look at this, we essentially have half this horizontal distance, and we have half this vertical distance. So those are the values that we use. So now we can start writing our point. Since we are going from A to B, that means we start at A. So my starting x is -2. My starting y is 8. Now, to get from -2 to 4, I increase. So I'm going to be adding because I'm going from -2 to +4, and that means I'm getting larger. The 8, I start at 8 and I go to -10. That actually means I'm decreasing, so I'm going to subtract. So these signs are determined based on, am I increasing or am I decreasing? Then we have our fraction, so half, half. And then we have our horizontal distance and our vertical distance. So our horizontal distance is 6, and our vertical distance is 18. Okay, so now we simplify down. And when we are simplifying down, we'll have -2 plus 3, and we will have 8 minus 9. And -2 plus 3 gives me my +1, and 8 minus 9 gives me my -1, which is exactly what we expected the answer to be. So I chose to do the midpoint just because I wanted you to see that this does indeed produce the value that is halfway between those two. But let's kind of summarize the process that we do here. So first, we find horizontal and vertical distance. Then, after we have found our horizontal and our vertical distance, we then need to determine starting point, which will be determined for us here. This gives us our starting x value, which I will call x naught, and our starting y value, which I will call y naught. 3. Do we add or subtract? And 4, put everything from 1 through 3 together with that fraction. So, I will put it this way, and it's kind of the formula that I wrote down in class. Our starting x value plus or minus our fraction times our horizontal distance. That is our new x coordinate. Our new y coordinate is y naught plus or minus whatever our fraction is times the vertical distance. I will point out at this juncture that this is not the only way to do this problem, but this is the way that I think is easiest. I have a video on my channel as well that discusses a systems of equations approach, if you would prefer to look at that. and I will be happy to discuss that with you, just not as a whole class. Thank you very much. I hope this helps, and I will see you when I see you.